recording. Yep. Go ahead, Vasileios.
Okay. Thank you, Kenneth and the EasyBuild community for inviting me for this talk. It's now, I think, the third year we're giving like the advances in ReFrame, and thanks for hosting us here. Yeah, I'm going to present the advances that from last year that I did the same presentation in ReFrame. It's a work that's done not just by me, it's like several developers and from different institutions. So I'm just taking here the step to present that work and what's new and what I think would be also interesting for this community. Again, I'm doing a short recap. I believe most of you know what ReFrame is. I'm just doing a wrap up. So it's essentially a testing framework for writing system and performance tests for HPC systems, but not necessarily on HPC systems. Tests and configurations are in Python. There's support for multidimensional test parameterization. There is different support for different HPC schedulers, module systems, build systems, support for parallel execution of tests, dependencies, and so on. I'm not going to go through the whole list just to save a bit of time. One big announcement is that we just released 4.6, basically this weekend. And the big new thing with release 4.6 is the new documentation. So essentially, the old tutorials have been completely replaced by a new tutorial that covers all the new and the modern aspects of ReFrame features such as variables, parameters, system and environment constraints, and so on. So even if you're an existing user of ReFrame, or even if you have used it a lot, I would still suggest to give it a try, because I'm sure there will be things there that would be useful and let you know what's new essentially in ReFrame. And the other good thing with the new documentation is now fully containerized. If you remember, the old docs were based on Daint and then examples on the CEST system and Daint. But actually, the problem was that everyone who was trying the tutorial would have somehow access to a HPC cluster and adapt the test. Now, this is not needed anymore. The tutorials are fully containerized. So we have Docker containers like for single node tests, single node exams, but also Docker Compose with Slurm that can emulate for the purposes of the tutorial a cluster. So then you can try everything on your laptop, get familiarized with ReFrame, and then before applying it to your own cluster. So actually, when I started preparing this presentation, I thought, okay, we're not going to have like many features maybe, but eventually as I made the list, turned out that there's lots of things that have happened since last year. So I will start now showing what's new, and later on also some more important features. I will also show some examples. First thing is that now the Bootstrap script, if you install through the Bootstrap script, now there is support for multiple platforms. Now, what was happening in the previous versions were that, for example, if you had a login node and some compute nodes that were different architecture, then you would also want to run a ReFrame from the compute nodes, that wouldn't be possible. You have to have different completely installations in different paths. Now, if you run the Bootstrap, it will basically fetch all the dependencies in platform-specific directories. It also supports pipless environments, and it actually now the Bootstrap fetches the pip for the actual Python version. So that's also solved several issues that we had. For example, we have some distributions, and Bootstrap was working perfectly in another node, and usually was related to pip. Some distributions offered by default, some others no. We have some new parallel launchers contributed, like the PDS8 and from the cluster cell launcher. And then we have also a new scheduler backend. This is something I wrote like last summer. Essentially, it uses SSH to copy the test artifacts to remote host. It doesn't assume that the remote host has ReFrame or anything related to the test. So it's a completely different host without any shared file system or anything. Launches the test on the other side, pulls back the generated artifacts. It's fairly, limited at the moment, but it seems that people have started already using it and already did some requests of supporting like multi-node jobs and using, for example, host lists and things like that. Yeah, we might expand this upon request. And another thing I forgot to mention, that now you can define your own custom scheduler backends without having to change the framework. If you ever had to define your own scheduler backend in the past, you would have to keep a modified version of ReFrame, a modified fork. Now this is not necessary. You can have your scheduler backend in a different file and simply import that in your configuration and register the scheduler backend with the framework, and then it's ready to be used. The same way as with custom parallel launchers. There is now some improvements regarding configuration of environments. There is a prepare CMDs environment level configuration option to emit commands just before the environment is loaded, like the module loads, etc., for the environment. And there is another, let's say, enhancement that fixes a problem. For example, when you're, for example, a GIN node, your head node didn't have a module system, and then, but you still wanted to use a module system on the remote nodes, that currently wouldn't be possible because ReFrame, what it does is essentially, by default, it has the feature of conflict resolution, tries to load the modules locally and see if there are any conflicts. But once now you turn that off, this does not happen on the head node at all. So no module load, nothing. So ReFrame will simply take for granted that the compute node has the modules, the module system. So that facilitates a bit things. There is also in the environment, you can now set also NVCC. And there's some also improvements with the SPAC integration. So there's now options to pass options to the SPAC env create command, and also options just before doing the SPAC install. There are more info that is now exposed at the processor info. So for example, since some versions in ReFrame does an auto detection of the host topology and also the processor architecture using behind the scenes art spec for that. And that information is available in the test through the current partition.processor variable. Now it's also available the model and vendor, so you can also use those features to differentiate your tests, and also the platform like ARM64, x86 64. That's useful perhaps if you want to play a bit with containers and load containers. Another thing that has been there has been a bug or a feature request since a while, and I think it was also like from Oke here at Ome, and about the flexible node allocations. There was ReFrame can distribute a test on all the nodes that they are supposedly idle in the cluster, but there was an annoying tweak there that it was selecting any node that was in an idle state. But the problem with Slurm is that nodes can be in multiple states at the same time. So for example, if a node was in idle plus drain, the ReFrame would still pick it up, although it couldn't run the test. So this has changed now, and states by default are matched exclusively. So when you say distribute equals idle, it will only select nodes that are strictly in idle state. If you still want the old behavior, you can use a star and say like idle start. And there is also another option being introduced, like a pseudo state called avail, and will select any node that is exclusively in any of the allocated idle or completing states. And the reason why this is useful is sometimes you are willing to wait until, because you need to test, for example, all the nodes, and you are willing to wait if there are some others job. So, but you need to submit on all the available nodes in the system. There were a few improvements also in logging and performance logging. So now the submit time can also be queried from the logs, the job submit time, and this is actually, this is the submit the time that the ReFrame actually submits the job. There is also a new placeholder, a special one that's called check _hash all. And that will select all the loggable variables to be logged in the perf logs, and essentially equates somehow to what is already being done with other login handling, with other handler backends, such as those sending data to Graylog or Elastic. And essentially now the perf log is much more verbose by default, but this, of course, you can always reduce that based on your requirements. There is another improvement, is that when the perf log format changes, now ReFrame will not just override it blindly. It will save the old one and will create a new one with a new header. So you won't have any more like mixed logs. And another change is now that parameters and variables are loggable by default. Another interesting feature that I find quite useful as well is that now you can parameterize tests from the command line. So imagine that you have defined a variable named numNodes, then you don't need to create this boilerplate code, basically, that you inherit the test, create a parameter, and set the numNodes. That can be done automatically by the framework, provided that your test defines variables. So then you could say -p numNodes 1, 2, 4, 8, 16, and then ReFrame will generate all these tests and run them. And you can do for any variable. So, and you can pass this option through multiple times. So then you can even create on-the-fly parameterization spaces. Another short improvement about how you could set like nested mapping variables. This was not possible before, but now you can still use the -s option to set like a nested dictionary. I have a typo here. It should be like the name of the variable also. Now, another limitation that the framework had was the auto detection, the auto detection of the system and how the system configuration was selected. So you know that this is happened by the host name. So what ReFrame does is runs host name and tries to match the retrieved host name to any of the host name patterns that there are in the system configuration. Now this is problematic for cloud environments where you get like a random, let's say, name and doesn't correspond to the instance. And then there is also the thing that, for example, every cloud has different naming convention and different way to retrieve what the instance you're in. So what has been introduced is that you can now define custom methods to generate that key that will then be matched against the host names in the system. So that could be, for example, a Python function, like in this example, where I'm just retrieving the instance type, and then you could say in the host names that that partition is called M5N large, and that's what you should check against. to select it. But it could be anything. It could also be a custom command that you can pass either in the ReFrame auto detect methods environment variable or a custom script. And then you control completely how you index your systems and how you generate that key. Continuing on. So here, like the launcher wrapper, I don't know if many are using that feature. That was mostly of being able to wrap the parallel launch command, say MPI run or srun, with something else. That is useful, for example, when you want to launch a debugger and test a debugger, for example. So this is now deprecated, and we introduced at the launcher level the modifier and modifier options, which will be prepended to the srun command. And another little improvement is that compile-only tests, you don't need anymore to define a validation, a sanity function if you don't want to, because by default, the test would fail in any ways if the compilation fails. And going now to the constraints, just doing a sort of wrap up here. So if you remember, like recent ReFrame versions, you're not required to put invalid systems or valid programming environments, full system names or partition names or environment names. You can put features or other constraints, and then ReFrame will match all the partitions that partitions in the environment that satisfy those constraints. So for example, and now by default, what you do, the scheduler and the launcher partition are available as extras that you can use in your test. So you could say that if you put in your test valid systems scheduler slurm or scheduler SQ, it means that this test will run on any system that has the scheduler. And similar, if you say launcher MPI run, it will run on any system that assumes MPI run. And that's quite useful. For example, if you want to do in your test some like MPI run specific options to pass just in your test, then it's good that you constrained it so that it's not going to run on other systems that have, for example, srun. Now, another improvement that's also towards the idea of increasing the composability of tests, also in the view of creating like libraries and making it easier, is that you can now inherit multiple times a variable. So imagine the example I have here to the right. If in previous versions, and if I didn't have this merge func here argument, this example would not it would fail in a ReFrame and would say that the class C cannot inherit cannot define multiple times the X variable. Now, this is problematic, for example, in cases where you want to use mixins and to define variables that have a bit like, to be more like utilities that you want to use in your tests or test libraries. So we added this new feature, this new argument, merge function, which essentially defines how you would combine the variables, the existing one with what you set in your current test. And in this case, we say we just get the maximum value of the items. Now it might not be quite obvious what would be the big benefit of it, but imagine that, and we're looking into, for example, extending valid systems and valid proc environments so that you could define them higher in the hierarchy, and then those to be extended with more constraints as you specialize your test. So then eventually, if you have like a constraint that comes that I want the system that has, I don't know, the feature GPU, and then I want another system that comes from another like base level that I want like SRAM scheduler, SRAM MPI launcher, then I would need to combine those two. And the resulting test should have the combination of those two constraints. So you need that thing to be able to support this multiple inheritance. That's why we added this, and makes the test much more composable. Another thing that has been a bit, if you have been working like with ReFrame and trying to make also tests that are kind of reusable, you would end in the pattern where, for example, I want a base test where I have defined how my test is going to run, and then I might have some site-specific subclasses. And ideally, you wanted that, for example, just before submitting to assemble the final, let's say, test command line that you're going to run, the executable. And you would use that usually with hooks. But the problem is that the order of execution of hooks in ReFrame was very specific. So they follow kind of the reverse MRO order. So for example, imagine that have those example with X and Y test and ignore for the moment the always last. The order of hooks for the run states in this example would be first hook A from the base class, then hook B, then hook C, then hook D. That's problematic in the sense that you can't put in hook A in states run something and you expect that you have all the information that the subclasses changed in the test. So that's why we've introduced this new argument to the run before and run after decorators that's called always last. And that's essentially will append essentially the hooks in MRO order this time at the end of the list. So with this example, for example, the order would be first the hook B, then the hook D, then hook C, and then hook A. So in hook A, it's guaranteed, because it's the first that defines always last here in the hierarchy. It's guaranteed to be the last hook to run on the run states. So there is safe to say that I have all the information to construct, for example, the final command, executable command line that I want to run. And that's really unties your hand and makes the logic much easier to composing tests together. Again, on the idea of composing tests, test composability, and of creating like libraries, is support for relative imports. So inside the test files. So imagine this setup where you have a test library, and then it has a simple check in the simple.py file, and then some utilities, because you write the library, you need some utilities that are defined here. And then you have a final example that uses the library to extend it, your site-specific thing. And here is the imports. And in the test lib sim, you just need to import your utility and do this thing from .utility import a dummy fixture. Now this would work fine if you were to run the test lib example. But if you were to run the library, it would fail because Python wouldn't be able to import it. Now, what we changed a bit the way ReFrame loads the tests. So whenever in the hierarchy, when you ask to load like test lib symbol, when it encounters an init.py, and this can be empty init.py, it will load the module, it will load the test lib init, and we'll use that as the parent module of whatever gets imported later on. So when simple.py then we're going to do from .utility, it knows that simple has a parent that's called testlib. So Python knows where to find init. And this way you can either run immediately your site-specific part or your generic test for example, when you want to explore a new system or a new setup, and so on. And that basically concludes all the features. I think I am in time, hopefully. Yeah, for future outlook, we have been currently looking a lot into improving like reporting and post-processing of reports. This is not an easy topic, and yeah, we're also considering perhaps writing a sort of external tool parallel to ReFrame, shipped with ReFrame as well, that could parse like the reports of ReFrame and do also some queries. Also, for example, using perhaps some libraries like pandas, etc., but not be the ReFrame itself, be something parallel to be able to let you compare results of different runs. And also we're considering ways of storing the results like in a database. Other things that might end up in the future is, as I alluded before, where we have also a proof of concept that works like for valid systems where you can incrementally add constraints as you go down the hierarchy of tests, and this the constraints are expanded, and the same would be for valid programming environments. And also another thing we're considering is improving the way references are defined, apart from considering also like a database, but just in the test, because currently references are defined by system and are indexed, let's say, by system, which is a bit restrictive because your test might have parameters and the reference might change based on the parameters you set, or you might don't care about the system, but rather on the GPU architecture that you have or the CPU architecture that you have. So the idea there is that we expand references in a way that you can create a custom index on the references, and then say, for example, that the reference I'm putting here are indexed by this X variable of the test. And then ReFrame automatically will do the work to get the right reference based on the variable value or on some of the metadata that it has collected about the topology of the processor. And then we've tried to drop Python 3.6 like a year ago, but then we got pushed back by the community because CentOS 7 is still using it, where many centers using still CentOS 7. So now CentOS 7 is going end of life, I think in June, if I'm not wrong. So we're planning also to drop support for Python 3.6, which is, by the way, also end of life. So that's all about it. And yeah, thanks for having me.
Excellent. Thank you, Vasileios. Do we have any questions for Vasileios on ReFrame? Sam? Yeah?
You can hear.
Thank you, Vasileios. About specifying parameters on the command line. You can do that for variables. Can you also do this for parameters that are defined in the test?
No, but that's in the pipeline to implement as well.
Okay, yeah.
There is an open issue, but currently it's not supported. But yeah, we would like to add support for this.
Okay.
But what do you see happening in the future with the HPC test lib you have now in ReFrame? I know there was some discussion to maybe pull it out as a standalone thing or something you install on the side.
Yeah, I think that's valid. I mean, to have it like a separate repo. Now the thing is that like we're not actively working on the library like per se, but we're still adding like features that would be useful on like increasing the composability of the test. And the reason for that, like it's lack of resources for the library, because it also needs a use case, in my opinion, like to just like adding like randomly, like this is how I imagine the test. It's a bit dangerous, I would say. Instead of like, I start off from something that I have, and then I extract something that I will build upon. And that's also a call like for the different sites that use ReFrame to, yeah, I mean, try to generalize, and then like we could see how we can make that in a library that's useful and basically being reused. That's how we view it.
Yep.
The auto detection of the hardware pieces, have you fixed it so that it first checks if you have the ReFrame module installed on that system?
No, this has been slipped a bit back, but
again,
you mean the remote auto detection, right?
Yeah.
The remote, yeah. So yeah, that's something we're gonna like. I would say the past months, like primarily the 4.6 release, which was mostly rewriting the docs. So now, we are freed from that. I see there is more time to get back onto fix once and for all those little remote auto detection issues. There are 3 or 4 of them that I think should be addressed.
Yeah, I tend to forget to update my patch for that for every new release, and I get confused.
Yeah.
Maybe one more, combined to your last bullet point here. I expect you'll get pushback on dropping Python 3.6 since it's the default in RHEL 8 and friends. But let's see. It is, I think, pretty easy to install.
Yeah, I will do a
Python
poll
3.9.
And maybe I will do a poll.
Maybe connected to that, and I think I warned you a couple of years ago, if you start open sourcing a tool, that you may start a community. How happy are you with that now? Like, is the community helping you, or is it just giving you more work?
No, I think overall it's quite positive, because the framework wouldn't be at this point if it wasn't for the community. I mean, all the interactions, the different use cases, it's really eye-opening. Otherwise, it could be just a tool for a single site, which would make it very restrictive. And then now we're also at the point where we're discussing that, okay, we have like tools that they do the work. So let's think beyond that. So that's quite important, because otherwise we would end up doing again and the same thing.
Yep. All right.
So it's definitely a big plus.
Good. Thanks a lot. I think we'll wrap up here. Thank you very much, Vasileios. I think this has worked fine as a remote talk. And I'm sure we'll see you again in the future EasyBuild meeting.
Yeah, thank you.
All right. Thanks.